All right, hello calculus friends. We have a new section of notes today that is called proofs, and I'm just going to call it proofs of trig rules. And proof of trig rules is really going to have to do with derivatives, and we have some derivative rules already. We know the derivative of sine of u is equal to cosine u times u prime. We know the derivative of cosine of u is equal to negative sine u times u prime. And we know the derivative of tangent u is going to be secant squared u times u prime. Okay, today we're going to have some new trig rules, and we're going to deal with cosecant, which is going to be related to is 1 over sine. We're going to learn how to do secant, which is 1 over cosine, and we're going to learn how to do cotangent, which is just 1 over tangent, or we can think of that as cosine over sine. So let's go through and let's figure out some rules for those. So for the first one, we're going to do the derivative of cosecant u. And the way I'm going to come up with a rule for this is I'm going to rewrite cosecant as sine u quantity to the negative first power. And then we can see this is going to be a power rule. So the power rule is going to just say I'd multiply this by negative 1. This is going to become sine u to the negative second. This is going to spit out a cosine u. And then this is going to spit out a times u prime by the second chain. So this is the first chain, this is the second. And let's rewrite this in a different way here. So I'm going to rewrite this as negative 1 over sine u times cosine u over sine u times u prime. And through this, we can see that I can simplify this to be cotangent, and this is really just cosecant. So the rule, the derivative of cosecant u is going to be negative cosecant u, or times cotangent of u times u prime. And there is our rule. And one way I try to remember this is I know this is sine on the bottom, and I know there's two sines on the bottom and a cosine on top. So it's going to be cosecant and cotangent for that one. All right, let's do a proof and develop a rule for secant, which is 1 over cosine. So I'm going to rewrite this as we're taking the derivative of cosine u to the negative first power. All right, so let's use our rules here. This is going to be a power rule, so I would have negative cosine u to the negative second times, this is going to spit out a negative sine u, and then this would spit out a times u prime. And let's do some rewriting here. So I'm going to rewrite this. First of all, these are going to chippity-choppity right here. I would rewrite this as 1 over cosine times sine u over cosine u times u prime. And then now I can rewrite this as this is secant u. This is going to be times tangent u, and we would have times u prime. And that would be our rule. And we'll summarize these in the end. I'm just showing you where these rules are coming from. The last example we're going to do, we have to do the derivative of cotangent. And the way I would come up with that one is I would just rewrite this in a way that I know how to do the derivative. I would rewrite cotangent as cosine of u over sine of u. And this is going to be a quotient rule. So on the top here, we'd have the derivative of cosine, which is going to be negative sine u, and this would actually spit out a u prime. And then we'd have another sine u minus, then we would have the top, which is just cosine u, times the derivative of the bottom, which is going to be cosine u times u prime. And that is all over sine of u. All right, a couple things I noticed here. I noticed there's a u prime in each of these, so I'm going to factor that out. I'm going to take this out, and I'm going to actually write it in the end. Is kind of how the rule's written. So in the end, we're going to have a times u prime outside there. I also noticed that this is sine times sine, so this would be negative sine squared u minus cosine squared u all over sine, this should be sine u squared. And then I said I was going to take out that u prime from each of these and just put it outside. And then I can take a negative out of the top here, which is going to give me sine squared u plus cosine squared u all over sine u squared. I still have this times u prime. And then here we have sine squared plus cosine squared is equal to 1. So this is going to be equal to negative 1 over sine squared u times u prime, which is going to be negative cosecant squared u times u prime. And that would be our rule for cotangent. All right, so let's summarize our rules here. Here's our rule. The derivative of cosecant is equal to negative cosecant u times cotangent u times u prime. And a couple different ways I try to memorize this. First of all, I know if there's a cosecant, I know there's a cosecant in the front. And I know it's a cotangent because I know when it's 1 over sine in here, then I know this is a 1 over sine up front. And I know the sine is on the bottom for both of them. So I know this one is going to be my cosecant. I'll have my negative there. I know there's always a times u prime, but I know if the sine's on the bottom, it's going to be cotangent. So this is, long story short, this is what we need to be able to do and recognize. All right, and then the derivative of secant is going to be secant u times tangent u times u prime. And again, I know the secant's here, the secant's here, and I know it's secant because this is 1 over cosine, and I know it's tangent because I know the cosine is going to be on the bottom for this one. So that's why I memorized those. You have to remember there's a negative with the cosecant, and there's not a negative with this. So the cosecant is just the cosecant, negative cosecant. The secant is just a straight up secant. And then we got cotangent because I know the sine's on the bottom from this, and we got tangent because I know the cosine's on the bottom from this. And then we always have our times u prime. That's just from our chain rule. And then we know the derivative of, we just proved the derivative of cotangent u is equal to negative cosecant squared u times u. And again, I know the sine is on the bottom on this one because this is cosine u over sine u. I know that's going to have, the sine is just going to stay in the same spot on the bottom, and it's going to have a negative. This should be a u prime. So there's our rules. All right, so that's just some proofs of some more rules that we're going to be using. Those are going to be coming up in our slots in a few days, but I just wanted you to see more of a theoretical proof of where those rules are going to come from before we work on those slots.